Another way we can use to approximate the delta H of a reaction is to use what's called standard enthalpy of formation. And delta HF, as it's commonly known, will be written like this. And so we know delta H formation, and this naught, NaUGHT symbol, tells me that this is under standard conditions. So what is delta HF? Delta HF is the heat given off or absorbed when 1 mole of a compound is formed from pure elements. So we've seen this already before. H2 plus O2, 1/2 O2 technically, to give water. So we have 1 mole of an element being prepared from its elements, pure elements. The delta H for this reaction, if you remember, is negative 241.8 kilojoules. And so this could be labeled as a delta HF for water. And we can put the naught there if we're under the standard state conditions. So what does standard state mean? Standard state is a temperature of 25 degrees Celsius and a pressure of 1 atm. And I just want to mention that this is not the same as STP, standard temperature and pressure, when we're discussing gases. Standard state condition in thermochemistry is different. It's going to have these characteristics. As we see here, delta H of the reaction can equal delta HF if we're talking about formation of 1 mole of a product from pure elements in their most stable state under the conditions given. So how do we know if an element is in the most stable state? Well, it's not that hard because most of the elements are either solids or gases. All of the metals and semimetals are solids, except for one, mercury. Mercury is a liquid. When it comes to the nonmetals, we know that the noble gases, as their name implies, are in fact gases. Then when we think about my diatomics, we have to keep in mind that these exist in their pure form as the diatomic element, H2, F2, etc. These are gases with the exception of bromine, which is a liquid, and iodine, which is a solid. And my other nonmetals, such as carbon, phosphorus, sulfur, etc., are all solids. So there's a handful of gases, about 2 liquids, and everything else is the solid when we're talking about their most stable form under standard state conditions. That's 25 degrees Celsius or 298 Kelvin and 1 atmosphere pressure. Let's see if you can apply this definition of delta HF and pick from this list of 5 which of these reactions would correspond to delta H reaction equaling delta HF under standard conditions, 25 degrees Celsius and 1 atmosphere pressure. Thanks for giving that a try. Now, let's look at each response and talk about why it is or is not the correct answer. In A, we have carbon in the form of graphite reacting with hydrogen and oxygen gas to produce ethanol. And in this case, remember the definition is delta HF is when 1 mole of a product is formed from pure elements. In this case, we are forming 2 moles of a product. So this cannot be a case where delta H of the reaction equals delta HF. In part B, we have 2 constituent elements as products. And this would be the opposite of delta H formation. We are not forming 1 compound from pure elements. And in equation C, we have 1 mole of a product being formed from pure elements, and then we have to say, are they in their most stable phase? Well, aluminum, okay, that's a metal, it's a solid, as we would expect. Oxygen, O2, one of my diatomics. Gas phase, good, Okay, so this seems to fit the definition just fine, and we can select this as an appropriate answer. Delta H reaction for this would be equal to delta H formation. In D, we have nitrogen and hydrogen making ammonia. This is incorrect for the same reason as A. We are producing 2 moles of a product. And E is another one that might have kind of caught our attention. We are forming 1 mole of a single product here, but we have to look at the elements that we're using to combine them. Sulfur is in fact a solid at room temperature and 1 atmosphere pressure, so that's fine. But then oxygen is not in the most stable form. The most stable form of oxygen is going to be O2, my diatomic. This is ozone, O3. So this is not the elemental form of oxygen, and therefore this cannot be a delta HF equation. Okay? Thank you for watching.